The next talk is presented by Grid Dynamics' own head of data scientist, Ilya Katsov. Ilya will talk about how to create advanced analytics services for your company and business partners on top of CDP. Over to you, Ilya.
Hello, my name is Ilya Katsov. I'm a head of data science at Grid Dynamics. Thank you for joining this session in which we will be talking about creation of advanced analytics services on top of customer data platforms. First, let me briefly introduce Grid Dynamics. We are a data science and software engineering consulting company headquartered in Silicon Valley, and we work with many retail, finance, manufacturing, technology companies, some of which you can see in this slide, on different types of innovative programs related to data analytics and AI in the areas such as customer intelligence, personalization, price management, supply chain optimization, fraud detection, and so on. And in this talk, I'm going to present some of the lessons that we learned through doing these projects of these companies. So basically, we are going to focus on three topics in this presentation. The first one is how customer data platform fits the business and operational models of financial companies, insurance companies, payment providers. Second is what services should be built on top of customer data platform and why do we build them? And finally, what are the best practices for designing these services? So to answer the first question, let us consider a couple of examples. First, let's take a look at the case of a payment provider that works with merchant clients and basically serves their transactions. And also, this payment provider can interact with consumers to resolve disputes, provide support, and so on. And internally, the payment provider most likely will have a customer data, some sort of a customer data platform to keep customer data, and the traditional use of this platform is to support this area of operations to interact with the customers. But in addition to that, this payment provider can also start to build different types of B2B and B2C services, and many payment providers do so. For example, a provider can start to build advertising services that provide different types of insights or offer personalization recommendations to the merchant clients, as well as developers of different types of applications and enhancements on top of their platform. And this way, they can monetize data, they can build a more comprehensive infrastructure around their core service, which is payment services. And they can also provide an extended range of B2C services, such as issue credit cards for consumers on behalf of their business partners, which will increase customer engagement, can reduce churn, and can help to collect more comprehensive customer data. And in this case, the role of CDP is basically much greater than just supporting interactions with consumers directly. In this case, they basically will be using the CDP to support these different types of services, both B2B and B2C type of services. In case of insurance companies, the situation can be actually somewhat similar, because traditionally insurance companies, they collect information about their customers, such as demographic information, household information about driving style using telemetry data, and so on. Some of this information is collected directly from consumers, some is collected through third-party data providers, and then this information is used to create B2C insurance products, to make decisions with regard to insurance quotes and so on. But insurance companies can also provide B2B services, and they frequently do so for insurance brokers to perform risk scoring, to do quotation, and so on. In that case, the overall layout becomes similar to what we've seen in the previous slide. Basically, the CDP needs to support not only direct interactions with consumers, but also support multiple internal and external teams that operate these different services for business partners and for clients as well. And in that case, we generally need to build quite comprehensive solution for this box for CDP that supports data consolidation from different sources and provides a number of services and capabilities to internal and external teams. The overall layout of such a solution in many cases looks as follows. Generally, companies develop quite advanced data capturing capabilities. It's quite common to develop, for example, different types of SDKs to capture data for web and for server-side applications, for mobile applications, provide different APIs and so on. And then on top of this collected and consolidated, companies often develop profile management capabilities, do data enrichment, do identity resolution, provide data discovery, support data quality checks, do privacy management, and so on. And then on top of that, some business capabilities can be developed, such as advanced statistical scoring of customers, development of personalization models, development of segmentation capabilities, and finally, the outputs of these audience management and profile management processes can be either made accessible to external parties through different types of APIs, or companies can integrate it with ad networks, for example, to run advertising campaigns on behalf of their business partners, like merchant partners, or they can provide self-service analytics capabilities, and so on. And these services can be used by both internal teams inside insurance company or payment provider, or they can be used by external business partners. In the rest of this presentation, we're basically going to look at some of these services in greater details and discuss what are the best practices for creating these services. So first, let's take a closer look at the data capturing capability and how this capability can be implemented as a generic service. So here there are several best practices that we generally adhere in doing projects in this area. The first one is that it's generally a good idea to provide convenient, comprehensive SDKs for external partners to capture data from web sources, server-side sources, mobile devices, and so on, so that it can be integrated with e-commerce systems and other digital and even physical properties on the client side. Then generally good idea to provide some relatively small set of standard integration patterns for internal teams, such as ability to ingest data from blob storages, capture data from APIs, capture data from event buses, so that internal teams can integrate with the solution quite easily and send in their data. And then once this data is received, we basically need to build quite a comprehensive and solid infrastructure to manage and process and transform this data. And typically the best practice here is to use principles of data mesh, which is the kind of reference architecture for building data management, data lake type of solutions. And in this area, we generally need to build some services to manage the infrastructure, in the sense how do we dynamically provision logical storages, logical compute capacities, how orchestration services work to orchestrate different data transformation processes, data pipelines. Then we generally need to build some data governance services to manage metadata, to control data quality, security, and provide data discovery capabilities so that at least internal teams can discover different data sets. And then on top of that, we generally need to provide different building blocks, different components to manage data as a product, meaning that the teams that are responsible for processing this data from these different data sources and responsible for making some data that can be consumed by downstream analytics capabilities of downstream system. They need to have a toolkit for building data pipelines, deploying these data pipelines in production, versioning both pipelines as well as data sets, and so on. And in general, it's a best practice to develop this array of different services that can be used to manage the data, and this data basically needs to be available both in transactional storage and in analytical storages for different types of use cases. Let's take a closer look at the data quality specifically. In general, once we receive the data from these external sources, this data often go through different types of transformation or enrichment stages. We need to do activities like data cleanup, like activity resolution, like data enrichment with some external sources or some lookup tables, and so on. And of course, some analytical processing as well. And in general, it's a best practice to develop services that allow to easily implement different types of checks for data sets that are inputs and outputs for these different stages of processing. And basically, these checks can be either deterministic, meaning that we check in data format, schemas, uniqueness of certain fields, values. We can also apply some custom consistency rules, but it can also be probabilistic checks when we are computing some sort of data profiles with statistics about typical number of files, typical number of records that arrive every hour or every day, and then we monitor the trends and detect anomalies in these statistics or in particular values in the certain fields that we collect. And if we detect some issues with data formats or some anomalies in data trends, then generally pipelines need to have some mechanism to prevent issues from propagation to downstream stages. In principle, all these three capabilities for different types of checks and for automatic blocking of data processing for downstream stages should be implemented as generic services that are provided by the data platform, and all data processors need to use them. Once we solve these basics, we typically need to develop some data enrichment and data enhancement services. And one case that is particularly important for this type of applications in financial industry is payment providers, is identity resolution. And this problem can partly be solved using in-house services, but in some cases we generally need to integrate with third-party identity resolution providers, because some cases cannot be solved using only first-party data, we need third-party data. For example, cases that can be resolved in-house include like reconciliation of records that are created across different channels. For example, if we have some record created in-store and some record created online for one of our merchant partners, then we can use either deterministic rules like email matching to combine these records together and resolve and map these two records to one identity, or we can use probabilistic rules that compute basically the distance between these profiles in some heuristic way, and or using some statistical model, and then we can match these records with a certain level of certainty, with a certain probability. Then if we have different types of online sessions that can originate on either different devices, or it can be some anonymous sessions, then we basically can match this record together using either mobile IDs or tracking device IDs, and resolve at least some of these sessions into one entity based on known sessions, based on logins that customer perform, and attach them to anonymous sessions. Then even if we have two different devices that produce different sets of anonymous sessions, we can still match these sessions together using some probabilistic techniques. For example, we can combine the sessions based on device type, based on public IP, based on travel patterns, so based on some behavioral features, and tell that certain anonymous sessions actually belong to one user based on this information. But in all these cases, we generally not able to use some external information, third-party data, and of course there are identity resolution vendors who specialized in doing this type of resolution that can resolve identity of a given session that we have in our first-party database through combining it with the information from third-party data providers from some external properties. Let's do a quick progress check here. So thus far we were talking about these data capturing capabilities. We talked about some of the data capturing services that we generally need to develop in this type of a solution. And we talked about some profile management capabilities that are needed to perform data enrichment, do identity resolution, do data quality check. So at this stage, this is, of course was not like a full list of services, but at least it provided some some idea, some overview of what kind of services we generally need to develop on this side to consolidate the data and make this data available for downstream processing. So in the second part of this presentation, I'm going to talk about these downstream services that use this consolidated data to get some actual business insights and provide some business functionality, including how do we convert this raw data into features that can be used for statistical modeling, how we organize this model management to produce some useful insights, how do we do segmentation and audience management, and how we make these insights of the scores available for outbound integration and data consumers of different types. So first, let's take a closer look at the problem of audience management in general. So what happens with the data that we consolidated using these techniques that we discussed in the previous slide. So typically, there are several ways of how this data can be used, and there are several tools that can help us to leverage this data in a meaningful way. One typical case is using segmentation tools to create audiences in a manual way. And typically some third-party products, standard products like Segment or Adobe Campaign are used to create these custom segments and then even configure some process automation flows that eventually are connected to some activation systems. For example, the segments can be sent to the paid media systems, ad networks. These segments can be sent to web systems, or we can run different types of email campaigns, contacting consumers directly using these process automation tools. The second thing that we can do with this data is to build different types of statistical models that replace this manually defined segments with some statistically derived segments. And these models, basically, we can build models that can help to quantify customer churn, probability of customer churn, can quantify lifetime value of a customer, can even prescribe what should be the optimal next best action for a given customer, or optimal next best channel to contact a given customer. And these models, they typically use statistical techniques like propensity scoring to quantify like the probability of response for a given customer, or quantify affinity between customer and certain type of communication, certain type of channel. And then the outputs of these models can either be consumed by segmentation tools, so that segments can be defined in terms of these scores rather than raw attributes, or these scores can be made available through APIs to our application developers who build some applications on top of our core platform, or can even be consumed by merchant clients. And the third type of solution that we also frequently see in practice is loyalty platforms that are used to configure loyalty programs, configure loyalty events and different business rules, how points, for example, assigned to customers and so on. And these platforms, they basically can consume outputs of the models as one of the inputs, and these business rules can be defined in terms of these scores. For example, customers with high lifetime value can be provided with certain benefits and so on. And then these platforms can be, the outputs of this platform can be integrated again with activation systems similarly to the segmentation tools. Now let's talk in more detail about how do we manage this machine learning box here, because in general it's not only about building models, but it's also about building more specialized infrastructure to manage models, to manage customer features, and in case of financial applications, one specific is that we generally need to build these capabilities for processing customer data specifically, as opposed to building just generic machine learning platforms or feature stores. And a few insights here is around building feature management capabilities and around organizing this overall modeling flow on top of it. One problem that we typically and frequently face in practice is that once we build different models, we of course need to do feature engineering that produces inputs for these models, and this feature engineering logic can be executed in different contexts, in different environments, such as model development. Then it can be scheduled. Once the model is trained, it might need to be executed in a scheduled mode for batch inference, or the model can be deployed for real-time production serving. And in the first two cases, we generally need to run this feature engineering logic on top of batches of profiles in batch mode. In case of real-time serving, we use individual records that come as a part of the request or fetched from transactional storage one by one. And in these cases, these cases are generally different, and in order to harmonize this logic execution, one of the best practice that we use is to create some sort of domain-specific language DSL that allows to specify the feature engineering logic in a storage-agnostic way, so that the same logic specified using this DSL can be executed either on top of these batch storages or can be executed in real-time mode for production service. Then once we have these features covered, once we have this part covered, this way we can start to build models on top of that. And there are different ways how it can be done, and in practice, companies, they often use tens or even hundreds of different models for different purposes. But in recent years, we see more interest in quite a lot of interest in using next best action type of approach for solving this problem in a more systematic way, as opposed to just building an array of many different models. So basically, in this approach, many companies, they start with some structured data like customer demographic data, clickstream data, but also there is a lot of interest in recent years in incorporating textual data if it is available, such as call transcripts, and extracting information about customer sentiment and other entities from this textual data using NLP models. And the next step is to understand customer behavior, understand drivers of customer behavior, why customers, for example, are churning, why customers are switching to alternative providers, and so on. As a second step, several propensity models can be built to quantify customer propensity to certain action type, like informational content or discounts, offers, or specific content topics or specific channels. And these models generally use both customer information and content information that can also be enhanced using different techniques that allow to extract data from textual descriptions of offers and so on. And then these different scores can be combined together in prescriptive engine that makes the final decision with regard to what offer should be used, which channel this offer or some other action should be taken through, and so on. And this way, marketing teams as well as digital systems, they can provide more personalized experiences all across. And in general, this framework, it helps to better understand customer behavior and make better personalization decisions and improve customer engagement in a systematic way. So to summarize, we talked about these different services all across the customer data platform and around it. In general, historically, we've seen that many companies are currently in the process of migration from basic customer data management capabilities to building these more advanced ecosystems that provide these advanced technical services, but most importantly, these services can support more advanced business services, both from B2B and B2C perspectives. So that's it. Thank you.
Wonderful. Thank you, Ilya. That was very informative. And thank you again to Grid Dynamics for hosting this wonderful event today. We do have a couple of questions from the audience. The first one is, how are the security concerns addressed in the CDP solutions you've described?
So there are actually several different security concerns that typically needs to be addressed in this type of solutions. For example, handling of PII information, services of external vendors. It also, from an analytical standpoint, frequently the case that field level encryption needs to be done so that different Also, there are some concerns related, for example, to GDPR that basically avoid ability to remove or.
Okay, great. And the second question we've got is, how long does it typically take to build a CDP solution for an insurance company?
So typically it is built, different layers of this solution. Independently, the data layer in many cases time to deploy because it's built predominantly upper layers like systems because it involves.
Okay, great. And it looks like that's about all the time we've got for the Q&A today. Thank you all so much for joining this great session, and keep an eye out for the pop-up that'll take us to the next session. We've got Favan Javed, Senior Director of Search, Data Science and Analytics at Kaiser Permanente, and he'll be talking about search and recommender systems for healthcare. We'll see you there.